Hey everyone, in this video we're going to solve some compound inequalities. So we're going to work through these 6 examples that you see here. Let's get right into it. When you have an inequality like this where you have something in between two inequality symbols, this is considered an AND type of inequality, compound inequality, where you can kind of separate it into two. And so let me just show you really quickly. You can say that this is -9, which is less than 1 minus 2x, and at the same time, this is 1 minus 2x is less than or equal to 13. But because the 1 minus 2x is in the middle, we can just smash it together like it looks here. So how we're going to solve is we're going to isolate x, and whatever we do to the middle, we have to do to the left and right side as well. So I'm going to start by subtracting this constant 1, but I have to subtract it from all 3 sides. And so then we have on the left, -10, keeping my sign the same for my inequality so far. In the middle, -2x, and on the right side, again, keeping my sign the same, this is 12. Okay, now this part, we're going to divide out this -2 so we can get x alone, and we do this to all 3 parts. Now, the only thing that's different about inequalities when you're working with them and instead of equal signs is that if you ever divide or multiply by something negative, so divide or multiply by a negative, you have to flip the symbol. Okay, so our inequality symbols are going to flip, and this is the only time that you do this. So now, when I go to my next step, on the left side we have 5. Now I have to flip this symbol, so this now faces the other way. In the middle, we just have x, and I have to flip this symbol. It also now faces the other way. And then we have -6 over here. And so this is the answer. Let's just make it look a little better because we usually write it with the smaller number on the left. So the same answer here, this is saying 5 is greater than x, and x is greater than or equal to -6. I want to write it like this. -6 is less than or equal to x. That's the same thing as saying x is bigger than -6. And then x is less than 5, which is the same thing as saying 5 is greater than x. So this is our answer. If we were to write this in interval notation, anytime you have a equal bar on your inequality symbol, like we have right under here, you're going to use a bracket. And then anytime you have no equal bar under your symbol, like we have on the right side, you use a parenthesis. And so x is greater than or equal to -6, but less than 5. So this is also the answer, but in interval notation. Okay, let's try number 2. So this time number 2, it's starting off as an OR inequality, so it's already separated. We have -x over 4 is greater than or equal to 1, or -x over 3 is less than or equal to 1. So we have to actually solve these one at a time because of this word here, or. It's not an and. We can't put them together. So I have to do each one individually. On the first one, I'm going to go ahead and multiply by -4. And I have to do this to both sides of my inequality. And then remember, we just talked about it. If you multiply or divide by a negative, you have to flip your symbol. So on the left side here, we're just going to get x when we multiply by -4 because these 4's divide out. Now this symbol has to flip because we multiply by something negative. And on the right side, we get -4. On the second part to our inequality, I'm going to multiply this one by -3, both sides. And again, I have to flip my symbol because I'm multiplying by something negative. So let me go ahead and just flip my symbol right away. And then on the left side, we have x. On the right side, we have -3. And then we put OR in between again. Okay, so this is our answer. X is less than or equal to -4, or it's greater than or equal to -3. And so let me show you what it looks like on the number line so you can understand why OR is necessary instead of the word AND. So if I plot just a few points here, I'm going to plot -4. Right next to it would be -3. Let me just put some other tick marks for reference. Here's 0. Here's 1. Now, look what this is saying if you think about the inequality symbol. X is less than or equal to -4. So that's over here. The next one says x is greater than or equal to -3. That's over here. And so it has to be this or that because there's no overlap. And so the other way you can write this in interval notation is all the way from negative infinity until negative 4. Now you have an equal bar on your inequality symbol up here. And so we're going to put a bracket. On infinities, we always put parentheses because technically you cannot equal infinity. And then we're going to jump over here to negative 3. We're going to put a bracket as well because of this equal bar on our inequality symbol. And then we're going to go all the way to infinity, again with the parenthesis. And then we have this nice symbol. It looks like a U. It's called the union symbol. And that is our answer in interval notation. So let's keep going. We're going to take a look at number 3 over here. The first thing that we actually want to pay attention to is the connection word. It's an and. So what we're really looking for here is where these two inequalities overlap or where they intersect. And we'll talk about that more after we solve. So let's solve each one at a time, and then we'll look for the intersection. So on the first one, I'm going to go ahead and subtract 4a from both sides, trying to get a's on the same side of my inequality symbol. And just to save some writing, let's go ahead and move the numbers to the other side. So I'm going to subtract 15 from both sides. And so what that's going to allow us to do is have all the a terms on the right. So that's 7a. And on the left, all of the numbers, and that's going to be negative 7. Notice we did not divide or multiply by anything negative, so our symbol didn't flip. And then one more step here, just divide by 7. And again, notice we are only dividing by something positive, so our symbol does not flip. So a is less than negative 1, or negative 1 is greater than a. So if we write it in terms of a is less than negative 1. Now, I'm not going to box this in because I have to consider the other answer and put those together. Now, over here, let's go ahead and move our a's to the right side. So I'm going to add 14a to both sides. And then at the same time, I'm going to go ahead and subtract 13 to move over my numbers. And then if you notice, our 13 is actually the same number on both sides, so that's going to add up to 0. So this is 0, this is 0. On the right side, we have a total of 11a. And then on the left side, all that's left, because this adds up to 0 as well, is 0. So I do have to do one more step here and divide out this 11. And so what we end up with is that 0 is less than or equal to a. But if we rewrite that with a first, it says a is greater than or equal to 0. Now, this was a compound inequality with and in the middle. And so now I have to think about what makes this true. And let me show you on the number line, because there is actually no solution here. Here's 0. Here's negative 1. Let me just put another few tick marks for reference. This says, okay, if we think about it, a is less than negative 1. Okay, so that's over here. This one says a is greater than or equal to 0. That's over here. Well, and means that there must be something in common. So the answer to this is actually no solution. And it's only because of the word that was connecting the two inequalities. If the word or was there, we can answer each part. But because it said the word and, that was the most important part. It's telling us we were looking for an intersection. So taking a look at the next one here, number 4, the first word to mention or notice is that it's and again. So we are looking for where these two answers are going to overlap. And so let's get right into solving. Let's go ahead and this time subtract 7t from both sides, moving our t's to the left. And I just do that because I'm trying to get a positive t value. So I'm going to move my 13 to the right by adding. And so here's what I was just mentioning. Now we have positive 1t on the left side of our inequality symbol. So you can move your t's to either side or your variable to either side of the equal sign. I just tend to move it to where it's going to be positive once I add or subtract. So the other one over here, let's go ahead and subtract 2t from both sides. And let's move over this 20, so subtract 20 from both sides. And then we end up with a positive 2t on the left, less than negative 6 on the right. And then one more step here, let's divide by 2. And we get t is less than negative 3. Now let's put the word and back in between. And so this is our answer, but let's see what this really looks like, because t is less than or equal to 11 and t is less than negative 3. There's a way more concise way to write this answer, and here's how. If I look at the number line, let me place 11 on here. Let me put 0 for reference. and negative 3. Okay, so let's go with t is less than or equal to 11. T is less than or equal to 11 is all of this. Then, if I say t is less than negative 3, well, that's just this part. But the question, going back to it, asked about and. When are these both true? What's the intersection? So that is right here. And so the final answer here is actually to say that it's only for t less than negative 3. That's when both of these are true. In interval notation, you can say from negative infinity until negative 3, and that's it. Okay, so that one was a little tricky, but if you keep your focus on the fact that it was and, we were looking for where they both meet or their intersection. Okay, so let's take a look at number 5 over here. Notice we have or, so that's going to be important for finding our answer. And then let's jump right into the first one. I'm going to go ahead and subtract x from both sides over here. At the same time, let's subtract 4 from both sides. And we end up with, on the left, 14, greater than or equal to, on the right, 7x. And then we will divide by 7, and we are going to end up with 2 is greater than or equal to x. And then our next one, I'm going to go ahead and subtract 5x from both sides. And so we have, at the same time, to add 15 to both sides, giving us 10x on the left, which is less than or equal to 20 on the right. Dividing now by 10, we end up with x is less than or equal to 2. Okay, now the word was or. Let's see what we can say about this. So let me just rearrange this one real quick for you. This says x is less than or equal to 2. If I just flip the way it looks, this also says x is less than or equal to 2. And so either one, they both say the same thing. That's the answer. X is less than or equal to 2. And in interval notation, we want anything from negative infinity all the way until 2. There is an equal bar on our symbol, so we're going to use a bracket there. And so this is our answer in interval notation. So ready for the last one. Let's see. Number 6. We have or one more time. And so we'll focus on that at the end. Minus 12 from both sides on our first one. And we end up with negative 4. N is greater than 32. And then let's divide by negative 4. And now we're going back to, if you remember from some of the beginning examples, dividing by a negative. So we have to flip our symbol here. So our symbol is going to flip the other way because we divided by a negative number. And n is less than negative 8. Okay, so moving on to the next one over here, I'm going to subtract 10 from both sides. And we end up with 12n is less than or equal to negative 48. We are going to divide by a positive 12. So we do not have to flip our symbol because we're dividing by something positive. So n is less than or equal to negative 4. And let's bring that word or back into our answers. Okay, so what does this answer really look like? Because instead of boxing this in, I should condense it if possible. So I'm going to look at my number line. Let's place negative 8 on here. Negative 4 would be a little bit further up our number line. Let me put 0 for reference. And so n is less than negative 8 would be this area. Over here, n is less than or equal to negative 4 would be all of this. And now we have to focus on the word or. So we want this amount of n's or this one. And so or, we can pick either one. And actually what we have to do is pick the whole thing. And so in this case, we want from negative infinity up until negative 4 right here, because that covers both of those answers to include the overlap, but also what worked for just one of them. So we could have just this part or this part, and so we take both, and so the answer is from negative infinity until negative 4 with a bracket on our negative 4. And if you want to put it back in our regular notation, just say n is less than or equal to negative 4. Okay, so that is some compound inequalities. I hope it's helpful.